Hello friends, you are watching channel number Collage. This is my sincere effort to help you understand basic mathematics in a simple and easy manner. In this video, we will solve problems on geometric applications of vectors. In the first question, we have line segment joining the midpoints of two sides of a triangle. We have this triangle ABC and DE is the line segment joining the midpoints of the two sides AB and AC. We have to show that line segment DE is parallel to the third side of the triangle, which is side BC, and it is half the third side. That is, DE is half side BC. In triangle ABC, D is midpoint of side AB and E is midpoint of side AC. We have D bar equals A bar plus B bar by 2 and E bar equals A bar plus C bar by 2. We have DE bar equals E bar minus D bar. That will be A bar plus C bar by 2 minus A bar plus B bar by 2. DE bar will be half times A bar plus C bar minus A bar minus B bar. A bar cancels with this A bar, so DE bar is half times C bar minus B bar. But C bar minus B bar is BC bar, so we get DE bar equals half BC bar. Since DE bar is scalar multiple of BC bar, we say that DE bar is parallel to BC bar. Therefore, segment DE is parallel to segment BC and DE is half BC. That is, length of segment DE is half length of segment BC. Hence the proof. In the second question, we have to show that vector area of a quadrilateral ABCD is, this is quadrilateral ABCD. In this quadrilateral, we have to show its vector area is half times AC bar cross BD bar, where AC and BD are its diagonals. We know that vector area of quadrilateral ABCD is vector area of triangle ABC plus vector area of triangle ADC. Now, vector area of triangle ABC is half times AB bar cross AC bar, where AB bar and AC bar the coterminous edges of triangle ABC, and vector area of triangle ADC will be half times AC bar cross AD bar, where AC bar and AD bar are the coterminous edges of triangle ADC. It will be half times AB bar cross AC bar plus AC bar cross AD bar. We will write this AB bar cross AC bar as minus AC bar cross AB bar. In the next step, we will write AB bar as BA bar, because of which this minus sign will become plus sign. Now we can take AC bar as a common factor and write half times AC bar cross BA bar plus AD bar. But BA bar plus AD bar is nothing but BD bar. So we write half times AC bar cross BD bar. Therefore, the vector area of quadrilateral ABCD is half times AC bar cross BD bar. Hence the proof. In question 3, we have to prove that the centroid of the triangle, we have this triangle ABC, and we have to prove the centroid of the triangle formed by joining the midpoints of the sides. So this triangle DEF is formed by joining the midpoints of the triangle ABC. The centroid of the blue triangle DEF coincides with the centroid of the yellow triangle ABC. So these are the medians of the triangles. G' is the centroid of the blue triangle DEF, and we have to prove that G' coincides with the centroid of the yellow triangle ABC, which will be G. Now, by centroid formula, we have G bar equals 1/3 A bar plus B bar plus C bar, where G bar is the position vector of this centroid G, which is the centroid of yellow triangle, and G' bar, which is the centroid of the blue triangle DEF, will be 1/3 D bar plus E bar plus F bar, which will be, in place of D bar, we will write B bar plus C bar by 2. In place of E bar, we will write C bar plus A bar by 2. In place of F bar, we will write A bar plus B bar by 2. That will be G' bar equals 1/6 times 2A bar plus 2B bar plus 2C bar, which will be G' bar equals 1/3 A bar plus B bar plus C bar. Therefore, we can say that the position vector of the centroid of the blue triangle G' bar equals the position vector of the centroid of the yellow triangle ABC, which is G bar, and this is what we have to prove. In question 4, we have to prove that the diagonals of a kite, this is kite ABCD, and its diagonals AC and BD are at right angles. This is what we have to prove. We know that the two pairs of adjacent sides of a kite are equal. That is, AD equals CD and AB equals CB. We shall use position vectors of various points with respect to point O. We will consider AD equals CD and write mod AD bar equals mod CD bar, which will be mod D bar minus A bar equals mod D bar minus C bar. We will square both the sides and write D bar minus A bar whole square equals D bar minus C bar whole square, which will be D bar square minus 2 A bar D bar plus A bar square equals D bar square minus 2 C bar D bar plus C bar square. After cancelling various terms, we get AD bar equals CD bar. That will be AD bar minus CD bar equals 0. we write this as d bar times a bar minus c bar. But d bar is od bar and a bar minus c bar is ca bar. Now since dot product of od bar and ca bar is 0, we conclude that od bar is perpendicular to ca bar, which also means OD is perpendicular to AC, which finally means diagonal BD is perpendicular to diagonal AC, and this is what we have to prove. In question 5, we have to prove that the perpendicular bisectors of the sides of a triangle, we have this triangle ABC, and OD is perpendicular bisector of BC. Therefore, we write d bar equals b bar plus c bar by 2 and OD bar perpendicular BC bar. OE is perpendicular bisector of AC. Therefore, E bar equals A bar plus C bar by 2 and OE bar perpendicular AC bar. F is the midpoint of AB. Therefore, it is sufficient to prove that OF is perpendicular bisector of AB. That is to prove OF bar perpendicular AB bar, which will finally prove OF is perpendicular AB. And this is what we have to prove. The perpendicular bisectors of the sides of a triangle are concurrent, that means they pass through the same point. This common point is known as circumcenter. In triangle ABC, we have OD bar perpendicular BC bar. Therefore, OD bar dot BC bar will be 0. Now OD bar is D bar and BC bar is C bar minus B bar. But D bar is B bar plus C bar by 2. Which will be C bar plus B bar dot C bar minus B bar, which will be C squared minus B squared equals 0. That is C square equals B square. We name this equation 1. Now we also have OE bar perpendicular AC bar. Therefore, OE bar dot AC bar will be 0. We write OE bar as E bar and AC bar as C bar minus A bar equals 0. But E bar is A bar plus C bar by 2. Which will be C bar plus A bar dot C bar minus A bar. It will be C squared minus A squared equals 0. That is C square equals A square. From equation 1 and 2, we write A bar square equals B bar square. In triangle ABC, we have A bar square equals B bar square, which will be a bar square minus b bar square equals 0. This can be factorized as a bar plus b bar dot a bar minus b bar. We will divide a bar plus b bar by 2. A bar plus b bar by 2 is position vector of the midpoint of AB, which is F. So we write a bar plus b bar by 2 as F bar. But F bar is OF bar and OF bar dot BA bar is 0, which means OF bar is perpendicular BA bar. That is, OF is perpendicular AB, which we show like this. OF is perpendicular AB, which proves the statement that the perpendicular bisectors of the sides of a triangle are concurrent. So, perpendicular bisector DO, perpendicular bisector EO, and perpendicular bisector FO are concurrent. They pass through the same point known as circumcenter. In question 6, we have to prove that a quadrilateral is a rhombus if and only if we have a quadrilateral OACB, which we assume to be a rhombus. It will be rhombus if and only if its diagonals bisect each other at right angles. OACB is a rhombus. Therefore, OA bar equals A bar and OB bar equals B bar. A bar, B bar. And mod A bar equals mod B bar, which means length OA equals length OB. In triangle OAC, we have OC bar equals OA bar plus AC bar. But AC bar equals OB bar. It will be OC bar equals A bar plus B bar. Now midpoint of OC bar will be OC bar by 2, which will be A bar plus B bar by 2. We name this equation 1 and we show it here. Also, midpoint of BA bar will be A bar plus B bar by 2, which will be here, and we name this equation 2. Now midpoint of OC bar equals midpoint of BA bar. Therefore, we say that diagonals OC and AB bisect each other. And this is the first part we have proved. In this quadrilateral, we have proved that diagonals OC and AB bisect each other. Now we will prove they bisect each other at right angles. For that, we will consider OC bar dot AB bar. OC bar is C bar and AB bar is B bar minus A bar. But C bar is B bar plus A bar. Therefore, it will be B bar plus A bar dot B bar minus A bar, which will be B bar squared minus A bar square, which will be mod B bar square minus mod A bar square. But mod B bar equals mod A bar. Therefore, OC bar dot AB bar equals 0. We know that when the dot product of two vectors is 0, these vectors are perpendicular to each other. Therefore, OC bar is perpendicular AB bar. That means diagonals bisect each other at right angles. Diagonal OC bar bisect diagonal AB bar at right angles. Now we have to show adjacent sides of this parallelogram are equal. For that we will consider OC bar dot AB bar equals 0. OC bar is C bar, AB bar is B bar minus A bar. C bar is B bar plus A bar. It will be B bar squared minus A bar square equals 0, which will be mod B bar squared minus mod A bar square equals 0. That is mod B bar equals mod A bar, or length OB equals length OA, which proves that the adjacent sides of this parallelogram are equal. Now, whenever in a quadrilateral the diagonals bisect each other at right angles and adjacent sides are equal, then it is a rhombus. So this is about applications of vectors to geometry. If you liked this video, please click the like button, share this video with your friends and relatives. Do subscribe this channel to get more videos of this type. Thanks for watching. See you in the next video. Keep watching Number Collage. Thank you.